Going to do this capacitor virtual lab, okay? It says open the simulation. The link is in Schoology. So in the capacitor assignment, you're going to download the attached document, which is this one right here, and then you're going to follow the instructions on this document, submit the document when you're finished, and click on the image on the assignment to open this lab. When it opens, you're going to select capacitance. Capacitance. It'll look like this, okay? Not light bulb, but capacitance. Okay, now we're going to follow the instructions, all right? Click on the capacitor, disconnect the capacitor, okay? Connect the capacitor to the battery. So this is how we disconnect and connect, all right? All the parameters should be selected, okay? Connect the voltmeter across the capacitor. We're going to put our positive end up here and our negative end down here, all right? And then we're going to do this chart and fill it out. Increase the battery voltage to 1.5. What do you notice is happening as we increase the voltage to 1.5? Okay, what happens to the charge plates? Okay, we're going to move our text box. They receive a charge. Okay, what's the charge on the upper plate? This is the upper plate. What's the charge? Positive. What's the charge on the lower plate? Negative. What's the direction of the electric field? All right, do you see the arrows? Do you see the arrows on the wires? The top arrow is going to the left, the bottom arrow is going to the right, so that is counterclockwise. So the direction of the charge is counterclockwise, okay? Potential difference across the capacitor. How can we determine the potential difference? Not going to worry about the potential difference, okay? So if it helps you, you can put a shape over this column. It doesn't really matter. We're not going to worry about that. But if you notice up here, the capacitance is already marked, so it doesn't take any time to just add that to the column over here. So 0.30 PF, okay? Decrease the battery voltage to negative 1.5. Coming down here, what's happening? The charge is reversing. Okay, our capacitance is the same, but these are opposite, okay? And if you noticed, the arrows are going clockwise now. So what happens to the charge plate? The charges reverse. Okay, the lower plate is positive, the upper plate is negative, and the direction of the electric field is flowing clockwise. The capacitance is still 0.30 PF. Okay, keep the battery voltage at 1.5 and increase the plate area. So you're going to do that by dragging this. Okay, Make sure you are observing what happens. Okay, what is changing on the screen? Not the voltage is staying the same. As the plate area increases, so does the capacitance. Okay? What happens to the charge on the plates? Let's see. The charge on the plates increases the upper plate is still positive, the bottom plate is still negative, and the direction is still counterclockwise. And this changes to 0.59. Decrease the plate area. So less than 200. All right, what happens? The capacitance is the only thing that decreases. Okay, so all of this is going to stay the same. I'm just going to move that down. And this number is going to change, 0.15 pF. Keep the battery voltage at 1.5 and decrease the separation. So let's put this back at 200, what it started at, I believe. Decrease the separation. So when the plates get closer together, what happens? The charge increases. Okay. The top is still a positive plate. The bottom is still the negative plate. The current is still counterclockwise, but the capacitance is a lot higher now. It is 0.89 pF. Okay. Keep the voltage. One of these should say increase. So we will fix this and say increase the separation. All right. We're going to increase the separation all the way. The charge on the plate decreases. Top plate is still positive, the bottom plate is still negative, and it's still flowing counterclockwise because that's determined by the positive 1.5. But our capacitance is now 0.18. Okay, let's look at this. Discharging the capacitor. Click on the bulb from the bottom of the screen. Okay, make sure the capacitor is connected to the battery and its voltage is 1.5. Okay, it's connected, voltage is 1.5. Connect the voltmeter across the capacitor. Okay, positive end up here, negative end down here. All the parameters must be selected as shown. So we are looking at everything. Disconnect the charged capacitor from the battery and connect it across the light bulb. So it's charged, okay? We're gonna come right across here and record your observations in the table. Okay, so what's happening? All of the charge is leaving the capacitor, and we can see that the light bulb gets really bright and then it slowly goes out. So let's watch again. So we're getting a charge of 1.5, which is what our battery is, on the capacitor. And then as soon as we put it on the light bulb, our charge goes through the wires into the light bulb, and we can see the voltage slowly decrease, okay? What happens to the following? What happens to the charge on the plates? It decreases, okay? So you're going to need a text box. It decreases. Potential difference across the capacitor. We're going to ignore that one. Okay, what happens to the capacitance? Well, I wasn't paying attention to that. So let's go back, charge it, and the capacitance is currently at 0.30. So let's watch. The capacitance stays the same. Okay, energy stored in the capacitor, it decreases. All right, the glow of the bulb, it increases, then it decreases, okay? How can we charge a capacitor? Well, if you can see this, when it's connected to the battery, it charges it, all right? How can we discharge a capacitor? Well, once the capacitor has a charge, we can connect it to a load-bearing object. This light bulb requires a load, and then that's how we discharge the capacitor. What are the ways to increase the capacitance of a capacitor? How do we increase the capacitance? Let's go back up to the first page. This is the capacitance. How do we increase it? We decrease the separation, okay? We're going to skip number 4. All right, we're not going to worry about the potential difference. All right, on increasing the voltage of the battery, what happens to the charge of the plates of the capacitor? Okay, when we started at 0, or like a very small number, we had a small charge, 0.15. When we increase the voltage of the battery, the charge on the plates of the capacitor increases. Okay, that is a direct relationship. Yesterday we talked about an inverse relationship between the voltage and the number of batteries. This is a direct relationship. Okay, as one increases, the other increases. Or as one decreases, the other decreases. This is a direct relationship. And that's it. Submit your document.